Hello class, we're about to start section R3.4 graphing quadratic functions. So we have the effect on A on the graph of f of x is equal to ax squared. Now what I did here, I took the liberty of adding in the answers here because I know if I wrote on here it would jump and not actually line up with the particular sentence. So we could go up here. If A, we can go through this. If A is greater than 0, then the parabola opens up. And we know opens up means like a U shape. If A is less than 0, then the parabola opens down. We know that'll be upside down. If the absolute value of A is a large number, then the parabola is narrow skinny. If the absolute value of A is a small number, near 0, then the parabola is wide or fat. Now the effect on K on the graph of f of x is equal to x squared plus K. And typically K means your constant value. So if K is greater than 0, the parabola is shifted up. If K is less than 0, the parabola is shifted down. So that's basically if K is positive, it goes up. If it's negative, it goes down. The y-coordinate of the vertex is K. So whatever K is, remember your vertex is an X and Y value. So whatever your K value is will be the Y of your vertex. Okay, now we have the effect of H on the graph of f of x equals x minus h in parentheses squared. If h is greater than 0, the parabola is shifted to the right. So basically if h is positive, now listen, when it says if h is greater than 0, it's not talking about this minus sign in front of it. It's talking about whatever h actually is. So if you see x minus h, h is going to be assumed to be positive. If you have x plus h, then h would be considered to be negative. Does everyone follow that? Okay, so if h is less than 0, the parabola is shifted left. The x-coordinate of the vertex is h, so whatever h is, that is your x value. So this is the vertex form of a quadratic function. You have f of x, which we know actually means y, and it equals to a times x minus h squared plus k. And then h and k is your vertex. Okay, now we come down here to this table. I took the liberty of filling out the table as well. Now, what we have here, we have all of these set up in the form of f of x is equal to a times x minus h squared plus k. But actually, this right here, this k of x, is actually not set up in that value, but we will get to that. Okay, so we come here. We know the value on the outside of the parenthesis is your a. Inside the parenthesis is your h. If you look here, since this is a minus 3, your x will be positive 3. And then your k is, as it's seen, is positive 1, so your k will be positive 1. Now, according to what we just read as far as those definitions that you will have to memorize or familiarize yourself with, it says that it opens up or down. This is going to open upward because your A is positive. Shifted up or down, it goes up 1 because your K is positive 1. And then shifted left or right, it's shifted to the right because your H is positive. Does everyone follow that? Okay, now this is basically the same thing for this g of x, but I want to get here to the h of x. It's basically the same thing except for if you notice here, you do not have a k. It is not shown, so that's why your y value here is 0. Now, it also shifts upward because your a is positive. Now it says shifted up or down. Remember, this is dependent on k. K is 0. So it won't do anything. So you could just put a slash through here or put, it will not do anything. Okay, so now, and then you know it'll go to the right because H is positive. Now when we come down here, we have a negative 1/5 times x squared plus 13. Now, if you notice here with our vertex has 0 for x value. That means that our h, what happens is this here. This is actually still written in a form, but to write it properly, I'm going to write it over here. This is really this here to be a negative 1/5, and then parenthesis, x squared plus 0, and then plus 13. So this is why your h is 0. It's technically this here, but we wouldn't write x squared plus 13. We would leave it as x squared. Okay, so this is why we have 0 for x. The k is still 13. It's going downward because your a is negative. And then it will go up 13 because your k is positive. Does everyone follow that? Okay, so now it says which is the narrowest graph? G of x, because the absolute value of a is the biggest. You look here, we take the absolute value of all of these a's, this will end up being positive 3, which would be the biggest. So that is the narrowest graph. Now they say, what is the widest graph? We know the widest graph is the lowest absolute value. When you put all of these in the absolute value, 1/5 is actually 0.2. So that means that k of x is the smallest. And you know with the absolute value, all of these a's would be positive. Are there any questions on page 1?
So you always take the absolute value of a?
Yes.
Negative or positive?
Right. That's to let you know if it's, bigger or smaller as far as that is concerned. Okay, now.
I guess I have a question.
Okay.
Like right there, like the negative 1/5 x squared plus 10. Where does that go?
No, this is 0.
Oh, 0. Oh, it's okay.
This doesn't go anywhere. I did this in relation to this here because this explains why our x is 0.
Okay.
Right, because actually this is the equation, but we don't usually put a plus 0. So
no, that's great.
Just like h.
You said what?
Just like h of x.
Right. Yeah, we typically don't put a plus 0. So okay, now we could.
One more question.
Yes.
So the h of x, if that was written fractionally instead of decimally, that would still be 0?
You said h of x. Oh, that's because we don't have a k. See, that's different. Remember, we don't have plus a constant.
Okay.
Right. So you follow that? Okay, let me go back up here. Okay, so you said for this problem here, the reason why we had 0 for y, remember, y is dependent on this outside number. All of these have a,
I was wondering if x would be 0.
here?
If the a was a fraction instead of decimal.
Oh, no, it has nothing to do with that. Right. It's because we didn't have this inside parenthesis here. So remember, this doesn't have that. I was trying to show you where the 0 is derived from, because this is technically, this is the parenthesis this is supposed to have. Okay, do you follow that now? Okay. All right, now, we go here to example 2. It says, let g of x equals negative 3 times the parenthesis x plus 2 squared minus 4. Place the vertex in the middle of the table and then find a couple points on either side of the vertex and place them in the table. Then graph by hand. Now we look here. We have 5 points they want us to get. They want us to write the vertex here in the middle. What do you think the vertex is here? Negative 2, negative 4. Does everyone understand how it's negative 2, negative 4? Anyone need me to explain it? Okay. If you look up here, remember, this is h and this is k. And basically this is x and this is y. Okay? Now remember, I told you, if it's positive in here, the x value would be negative. And k is written as is. So that's how you get the x and the y. Okay, so this is the vertex. And you could label it or you could just leave it here, but we know the vertex is supposed to be in the middle. Okay, so what we could do is this here. We could take some values. We could just start with negative 4, negative 3, negative 1, and 0. Now, if you put this into your calculator, this will give us a negative 16. This will give us a negative 7. This will give us a negative 7. And this will give us a negative 16. That's after you put these values in your calculator or you do it by hand. And then we can graph it. We know 0, negative 16 would be here. Now, sometimes these points disappear. I don't know why, but sometimes they will disappear. So you need to mark them as I mark them. So you have 0, negative 16. You have negative 1, negative 7, which would be about here. Then you will have negative 2, negative 4, which is here. And then you will have, now if you notice, the negative 1, negative 7 disappeared. And then the negative 2, negative 4 disappeared. So it's going to disappear. So I just keep on plotting them. So we had negative 3, negative 7, which would be about here. And then we will have negative 4, negative 16, which would be here. So all of them should match up here. And then when you draw your graph, now listen, I don't have the points because they disappeared, but your graph should resemble something like this. Actually, I went up a little too high. Do that. It shouldn't go past the negative 4. So it would be negative 4. So it should look something like this. Of course, yours would be a lot neater than mine. Does everyone follow that? Okay, now we go here to state the domain of g of x. Now g of x, there's no restrictions on x. X could be anything because it's increasing and it'll keep on going. Actually, I should have put arrowheads at the end here to signify that it goes on forever. So now, so we will write this domain. Okay, since there's no restrictions on x, we will have a negative infinity to infinity. And as you all see, it's jumping, but you all know how to write this properly on your course pack. Now it says state the range. Now if you notice here, we are not going above negative 4. Negative 4 is the top of this parabola. We went over this before, that whenever you graph a parabola, you either have the maximum or minimum point. This negative 4 is the maximum point, and it's included. So we know over here this would be negative 4. Now if you notice here with y, all of the negatives would be included with y from negative 4 on down, right? So it'll be negative infinity to negative 4. And negative 4 is included. Okay, now we go to example 3. It says two functions of the form f of x is equal to a times x minus h parentheses squared plus k are graphed on the same scale below. Determine the signs of a, h, and k. So a will have to be positive because it's going upward. H is 0. And then k would be positive. Because remember, this is your x and y value. You notice it does not, yes.
How could we find out that h is 0?
Because it doesn't hit the x-axis.
Well, then it would be 0. Because h is x.
Yes, h is x. It doesn't hit, the graph does not hit the x-axis. So if it doesn't hit the x-axis, it would have to be 0. And then also, if you look here at the vertex, well, let's just look at the vertex. If you look at the vertex point is here, right? What is the x value? Yeah. So actually, that's what I should have used, saying the vertex. If you look at the vertex here, x is 0 for the vertex. And then y is positive at the vertex. H is always X of the vertex, and K is always Y of the vertex.